Hello everybody. Today we are going to start lesson 3.3 properties of logarithms, and we will learn how to condense and expand logarithmic expressions using the properties of logarithms. First of all, let's try to remember these properties. So the product property, logarithm base b of x times y, it's like when you distribute the log, give it to each factor inside. Distribute the log. If it is times between the parts, then we put plus. If it is divide, then we will do minus. Remember that always the exponent goes outside the log, so it will be p times log base p of x. If the base in the log it is 10, the log it is called the common log, and we don't have to write it. And base, it doesn't matter what's the base here, 10 or whatever any other base of 1, this equals to 0, because let me just remind it to you. In order to simplify the logarithms, the number in the logarithm, we have to rewrite it as a power. So 1, it came from 10 to exponent 1, as long the exponent 0, as long the base is 10, then we have to rewrite the 1 as a power of 10. The exponent goes outside the log, so it will be like 0 times log of 10. Log base 10 of 10, it is 1, and 0 times 1 equals to 0. Yeah? If base it is e, then the log is called natural log, and we have the same properties exactly. It's just that, remember, if the base in the log it is e, then the log is called a natural log, and the symbol to write it, it will be ln of x. So ln for log base e. And change the base of the log. This is a very important property. So instead of base b, we can write another base a. So it will be log base b of x equals log the new base of x to log new base of the old base. For example, log base 3 of 4 equals, we change the 3 into 5. It will be log the new base 5 of 4 over log the new base 5 of the old one. On page 181, we have few questions there. So express each logarithm in terms of log 5 and log 3. So I'm going to take the first question, log 75. As long as no base here written, the base is number 10, so this is a common log. It could be e or it could be whatever any other log. That we can simplify, we have to rewrite 75 as product between factors, so it will be log 75, it is 3 times 25, where 25 it's 5 square. So here we'll apply the property product property, in which a times b equals log a plus log b. It is given the condensed form, and we will expand it, and it is equals log 3 plus log 5 square. The exponent always goes outside the log, so it will be equals log 3 plus 2 log 5. The second one, log 5.4 equals, this is a decimal, so we will write it as a fraction, log of 54 over 10. Here we'll use the division, the quotient property, and this it will be equals log 54 minus log 10. Log base 10 of 10, it is 1. Now all we have left to do is to factor the 54. 54, it's 2 times 27, which means 2 times 3 cube. So instead of 54, we can write log 2 times 3 cube minus 1. We will apply the product property, so distribute the log in each number inside. So it will be log 2 plus log 3 cube minus 1. 3 goes outside the log, so it will be equals log 2 plus 3 log 3 minus 1. Let's try more. Express each logarithm in terms of ln 2 and ln 3. Already 54 we factored it before, so we can write ln 2 times 27, it is 3 cube, and equals, distribute the ln inside, so it will be ln 2 plus ln 3 cube. Exponent always goes outside the log, so it will be ln 2 plus 3 ln 3. Ln of 9 over 8, here we will apply the quotient property. So between it will be minus, so ln 9 minus ln 8. Factor 9 and factor 8, it will be ln 3 square minus ln 2 cube, and this equals, the exponent always goes outside the log, so it will be 2 ln 3 minus 3 ln 2. Evaluate each logarithms. So we have, I'll take the first one. Remember that the number in the log, you have to rewrite it as a power in simplest form. So let's see. Such that the power has the same base with the base in the log. As long the base is 4, I will try to rewrite 64 as a power of 4. So it will be log base 4 of 64. First of all, I'll put the rational exponent, which means 1 over 5, and then equals log base 4, 64 rewrite it as a power in which the base it will be 4, and this means 4 cube, all to 1 over 5 equals log base 4 of 4. This is power of a power, so multiply, it will be 3 to 5 equals, always the exponent goes outside the log, so 3 over 5 times log base 4 of 4, which equals to 1, and 3 over 5 times 1 is 3 over 5. Second question. So exponent always goes outside the log. It will be 5 times 2 ln E minus the exponent goes outside the log, 3 ln E. Ln E, it is 1. Ln E, it is 1. It will be equals 5 times 2 is 10 minus 3, which equals to 7. Remember that log base b of the same number equals to 1. So equals, as long the base in the log it is 6, I will try to write 36 as a power of 6. So it will be log base 6, 36 it's a 6 square, all of it to exponent 1 over 3, rational exponent. It will be equals log base 6 of 6 times between the exponents 2/3. The exponent goes outside the log, So 2 over 3 times log base 6 of 6, which is equals to 1. So all equals to over 3. The exponent goes outside the log. So it will be 9 times ln E plus 4 times 3 ln E. Ln E, it is 1. So it will be equals 9 plus 4 times 3 is 12. And this equals to 21. Expand the logarithmic expressions. So the number in the log, these are factors. I will write it again with times between them. So it is 12 times x to 5 times y to negative 2. And first of all, we will apply the product property. So we distribute the log in each part. It will be log 12 times changes into plus log x to 5 plus log y to negative 2. We can expand it more. 12, we can rewrite it as 2 square times 3 plus the exponent goes outside the log, so 5 log x. The exponent goes outside the log, minus 2 log y. We distribute again, so again we use the product property. It will be log 2 square plus log 3 plus 5 log x minus 2 log y, and finally it will be equals, the exponent goes outside the log, so it will be 2 log 2 plus log 3 plus 5 log x minus 2 log y. So it was given the condensed form and we expanded. Here, as long we have divide between, we are going to use the quotient property, and this it will be equals ln x square minus ln square root of 4x plus 1. And this equals, the exponent goes outside the log, so it will be 2 ln x minus, we have to remove this radical because the radical it came from rational exponent, so it will be 4x plus 1 all to exponent 1 over 2, and again exponent goes outside the log, so it will be equals to ln x minus 1 over 2 ln 4x plus 1. We cannot expand it more. If here would be times or divide between, we could expand it more, but for plus or minus, we keep it as it is. So log base 13 from 6 times a cube times b times c to 4. We use again the product property, so it will be equals log base 13 of 6 plus log base 13 of a cube plus log base 13 of b plus log base 13 of c to 4. We take the logs one by one in order. Here we cannot simplify more. 6 when we factor it the 6, it will be 2 times 3, so there is no power in. And the base in log is different than the number, so we keep it as it is. The exponent always goes outside the log, so it will be 3 log base 13 of a. Here b has exponent 1, so we keep it as it is. The exponent goes outside the log, so 4 log base 13 of c. Inside the log, we have division represented given by the fraction line. So we are going to use the quotient property. It will be ln of numerator 3y plus 2. If there is divide, we use minus ln. We have to rewrite without the radical in. So it will be 4 times y to exponent 1 over 3. And this equals, here we cannot simplify more, so we keep it as it is, minus the product, we will use the product property, so minus ln 4 plus ln y to exponent 1 over 3. And 1 over 3 goes outside the ln, so it will be ln 3y plus 2. Remove the bracket, so minus ln 4 minus 1 over 3 ln y. And this is the expanded form. Condense each expression. When we have to condense, we have to reverse the steps. So I see factor 4 in front of log. I know that the factor came from the exponent and I move it back. I see factor in front of the log, so it goes back in place the exponent. It will be log base 3 of x to 4 minus log base 3 of x plus 6 all to exponent 1 over 3. The rational exponent, it came from radical, so this equals log base 3 of x to 4 minus log base 3 cubic root of x plus 6, and minus between the logs, it came from divide, so log base 3 of x to 4 over cubic root of x plus 6. So the factor in front of the log, it came from the exponent. It will be equals ln x minus 4 to exponent 6 plus ln x to exponent 3 plus between the logs, it times from the product, so it came from the product, so ln x minus 4 to 6 times x cubed, or we can write ln x cubed times x minus 4 to 6. On page 183, we have to condense, so the factor in front, it came from the exponent. The factor, it came from the exponent, we have to condense. So it will be log base 2 of x plus 1 to exponent negative 5 plus log base 2 of 6x, all of it cube. And this equals negative exponent or plus between the logs, let's say. It came from product, so it will be log base 2 of x plus 1 to exponent negative 5 times 6 cube is 216 times x cube. Negative exponent, we converted into positive, so log base 2. Remember that b to negative exponent equals 1 over b to positive exponent. So because of this, I will put fraction 9, keep 216x cubed on the top in numerator, and this one I'll move it down. So x plus 1 all to exponent 5. From left to right, so the exponent, the factor in front, it came from exponent. We can write ln 3x plus 5 minus ln x to 4 and minus ln x minus 1. I will take the first two first, and because it's minus between them, the minus it came from division, so I will condense ln 3x plus 5 over x to 4 minus ln x minus 1, and condense again, it will be ln 3x plus 5 over x to 4 times x minus 1. Let's try more. On page 187, write each set of logarithmic expression in increasing order. So we have 1, 2, 3 logarithms. We'll take it one by one and get its simplest form. So I will take the first one. Logarithm log base 3 of 12 over 4 equals log base 3, 12 divided 4 is 3, base and the number the same equals to 1. So I found the value for the first one. I take the second one and condense it, 36 over 3 plus log base 3 of 4 equals, simplifying side, it will be log base 3 of 36 over 3, it is 12, plus log base 3 of 4, condense, it will be log base 3 of 12 times 4, and this equals log base 3 of, let us get its simplest form, so 12 it will be 2 square times 3 times 4, it is 2 square, so it will be equals log base 3 of 2 to 4 times 3. So I will go back and expand it. It will be log base 3 of 2 to 4 plus log base 3 of 3. This equals to 1. And this is 4 log base 3 of 2 plus 1. So this is the second value. I'm going to write it here on the top. So the first one, it is 1. The second one, it is 1 plus 4 log base 3 of 2. And the last one, let's get its simplest form. It will be log base 3 of 12 minus 2 log base 3 of 4 equals, so 12, it came from 2 square times 3, and here 4, it came from 2 square, so instead of 12 and 4, we can write log base 3 of 2 square times 3 minus 2 log base 3 of 2 square equals product property log base 3 of 2 square plus log base 3 of 3. The 2 goes outside the log, so 2 times 2, it will be minus 4 log base 3 of 2. And 2, it goes outside the log. It will be 2 log base 3 of 2 plus log base 3 of 3 is 1 minus 4 log base 3 of 2. Collect the like terms and simplify them. It will be 1 minus log minus 2 log base 3 of 2. So then let's see. Increasing order, it means from the least one to the greatest one. This is the first, the second, and the third. So which one is the least one? It will be this. So 3, it's the least one. Greater than 3, it will be here because it's 1. And the greatest one, it will be the 2. And this is their order. Thank you.